Howdy, it's tubalcain again, and the subject of today's video is vertical shear lathe tools. This is a rather obscure subject and you won't find too much information on it, and it is seldom used and it has very specific purposes, and it's something I discovered 4 or 5 years ago, and I do use it on occasion, not very often, but it is a rather unique process. And let's take a look at the advantages and the disadvantages of vertical shear lathe tools. Vertical shear tools shear the metal off in a little bit different way than what you see on a regular lathe tool bit, but the advantages are it gives you an extremely fine finish, especially if you're having problems with difficult metals getting that good finish. And another thing is it doesn't tend to dig in like the other tools sometimes do, especially on light passes. And 3 I mentioned already is good for difficult to machine metals such as stainless steel and tool steel, and I use it on lead, and I'm going to show you a little bit of that in a while here. 4, the tool is exceptionally easy to grind, and I'm going to show you how to do that, but it's almost kindergarten play to grind that compared to regular lathe tools. It's easy to center the lathe tool on the lathe because there's just a lot of latitude in adjusting it vertically. It does not have to be exactly on center. And 6, you can raise or lower the tool a little bit vertically to get a new edge as it dulls. So you really have many edges on this tool ready to go without regrinding. And 7, it's an excellent way to approach that final dimension where you only need 1/1000th or 1/2,000th off, because going back to number 2 here, it doesn't tend to dig in. I think we've all had that experience of taking one more cut, feeding it in 1/1000th, and bam, all of a sudden it's taken off 2 or 3 and you're undersized. Now there's just a couple disadvantages now, and there may be more here. I may not have covered all of them, but the disadvantages are that it only removes 1 or 2/1000ths at a time. It is for finishing only, not for roughing. So if you have a lot of material to remove, you need to rough it in the traditional method with a regular lathe tool, and then change tools and come to the final dimension with the vertical shear tool, because it will only take off a few thousandths at a time. It is not capable of taking deep cuts. Several years ago I did a video on flywheels, machining lead flywheels, and I covered that briefly near the end of this video here, which is Shop Tips 163, so some of you may want to go back and look at that. This is a teaching aid I made of a vertical shear lathe tool, and this happens to be just 3/4 inch aluminum, not as big as I usually make my teaching aids, but I think big enough to get the point across. And this is the top of the tool. This is the side, and of course here is the end, or the actual cutting edge, but there's only 2 angles that you have to grind on this. That's what makes it so simple. Now it actually does its cutting right here on the end. Pretend this is the work, and this is the way the tool would approach the work. Now it looks like it's rubbing here, but as it's feeding, like this, that is how the cutting takes place. It's shearing the metal off, and you'll find that the swarf, or the chips, or the shavings have quite an unusual appearance compared to what you're used to seeing. Here's one of the tools I'll be using already mounted in the quick change tool holder, a Loris type. This is 5/16 high-speed steel. Again, this is the top. This is the left side, so you're only grinding in 2 places. Let's see if we can hold this work up against her again to see how it engages. So it'll be just like that. That's why I told you that the setting the height on the tool isn't very critical at all. And as one little area dulls, you can just raise or lower this a little bit. Doesn't have to be exactly on center. It's feeding along like this. Now the angles that we're going to grind this at are not that critical, and you can experiment with those, and there's quite a bit of latitude, but I'll give you a base degree or angle with which you can start, and you can practice on some soft steel, but it's so easy to do that you just can't miss. So let's take a look at the angles. Actually, I've ground two of these, and this is the A size of a Loris quick change type, and this is the B size. So I have one that I can use on the Atlas lathe and the other one on the Clausing lathe. But the tools are pretty much the same. They're 5/16 square, but you can make that any size as well. You could go with a quarter or 3/8 rather, or whatever you're in the mood, or whatever you have available in your shop. As you look at this tool from the top again, and check this with a square, you can see, of course, it's not square on the end, but in fact it is to be ground at approximately 6, 7, 8 degrees, something like that. It isn't very critical, and tries a variety of angles, a little bit more of an angle or a little bit less, and see how you do. Very forgiving. Notice that on my teaching aid here, I have stained one side green, because that's one side that you have to grind, and then the other black. So those are the only two surfaces or angles that you're trying to achieve. But looking at it from this way, and using the protractor here, I have approximately 15 degrees, but you can try 12, 15, 18 different degrees, and see if you get any results. And again, right along here, this corner here is where the cutting or the shearing will occur. That's why I'm telling you, you can raise or lower the tool in your tool post, and it's still going to cut. And just by changing the elevation a little bit, you're going to be cutting on a new portion of the tool, or literally getting a new edge. I have no intentions of actually going over to the grinder and grinding one of these, because you can see how simple it is. And the first time I do something, I almost always use some layout die on there and put the angles on with that protractor like I showed you. And then I even marked it that this is the left side and this is the top, but that's part of what I did for your benefit as well. And try to get a nice corner here. That's what it's all about. And sometimes a belt sander works pretty good, because you have a nice tool rest, except that the belt tends to flex a little bit away from the platen, and can be problematic. So a grinder really is better. Now, some people are going to tell you, then go over and hone it. And yes, honing would help, but I've found that with beginners, especially in high school, that sometimes they would grind a halfway decent tool, not a shear type tool like this, and then they would destroy it by honing and losing the actual edge or the portion that cuts. So, and they didn't understand that at that age, so I got away from telling them to hone it, and it wasted a lot of time, I think, in the school shop too, by honing. But you can hone it if you're good at it and you think it'll help. But this corner here is what it's all about. I believe I failed to mention a few minutes ago, or I misspoke, that this one that was in the tool holder actually is just cold roll steel that I used for practice some time ago. And I just ground another one out of 5/16 high-speed steel, and this is it. And I changed my mind. I'm going to show you just real quickly what the setup was on the grinders, on the belt sanders, to put those angles. I'm not actually going to grind it, but I'll just show you how I set it up in order to put those angles on. Let's step over to the belt sander first. I'm at the 6-inch belt sander now, and I've set the miter gauge for 7 degrees. And all I did here for that end angle of 7 or 8 degrees, or whatever you decide on, put it up against the miter gauge, turned the machine on, and just went back and forth. Now there was a pre-ground angle on the end of that, as there is on a lot of the high-speed steel, and that was about 7 degrees, so I just cleaned up that end. Then let's go over to the grinder. I'm going to move the guard out of the way because I'm not actually grinding, but that side angle that I just talked about was done like this. And the tool rest is set for about 12 degrees. I'll show you a side view of that. This is a tool rest that I made, and I prefer it over the original one. And you might have seen this in one of the other ones, but I just ground that angle on there like this and came up with that. I'll show you a view from this side now. Here's a side view of how I ground that. And this is the coarse wheel. I never did go back with the fine wheel, so we'll see how it cuts. I'm at the closing 12-inch lathe, and I just took a cut on 1-inch aluminum at about 900 RPM with a regular carbide tool, and I saved some of the swarf. I'll show you in a minute, and we'll compare it with the swarf produced by the vertical shear tool. So this is a pretty mediocre finish, and this is not a difficult to machine material, but I'm doing aluminum just to show you. And now I'll switch tools. Now looking at it from the tailstock view, here's the tool. And I'm going to take off about 1/1000th. Notice that the swarf is so fine that it almost looks like it's floating. Here's a bird's eye view, and this is the section that was just done with this tool. The part with the red X on it here, from here on over, was that carbide tool. I'm not saying there is a real big difference here between the two, but then again, this is an easy to machine material. 1-inch aluminum, and that was about 800 RPM with a 1,000th feed. And now we'll compare the swarf, but it's just interesting to see here the chip still coming off. And I'm just doing different samples here that I think are interesting to you, because they certainly are to me. These are the chips produced by the carbide tool. And then just a little bit down here, and these were hard to collect because they floated around. Those are the chips from the vertical shear tool.